To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.
Right, my dear children, now we are about to start a fresh new chapter. Within this chapter, we'll be investigating further things related to our solar system. Further extraordinary things related to our solar system. So you're given with an activity in here, right? So here, now in the earlier chapter, we discussed about the planets contained within the solar system and several information regarding the planets, about the distance from the sun, about the tilt and the orbit and the subplanets or the moons, and the rotational time, revolutional time, and so on. So within this part, my dear children, right, within this activity, we'll be building up a structure to identify the planets in our solar system. Small bit of a structure, right? Within this activity, we'll be building up a small bit of a structure, right? Small bit of a structure to identify the planets in our solar system. So to make this thing, my dear children, you'll be needing these materials, right? So first of all, you'll be needing several balls, right? These balls are to represent the planet. These balls are to represent the planets like the Mercury, Venus, Earth, Mars, Jupiter, Saturn, right, and so on. Okay, so we'll be needing several balls. So these balls can be rubber balls, plastic balls, or the quite easiest one is to find is styrofoam or rigiform balls. If you want, you can use any other different material as well, but however, rigiform balls are quite easy to find. So I'll mention as several like plastic or rigiform. Plastic or rigiform. Then we'll be needing paint. Paint. Okay, paint in different colors. Okay, especially there should be red color, orange color, yellow, and blue. Like that, we'll be needing several paints. Okay, you can use watercolors, pastel, any of the form. Okay, no problem. Then we'll be needing a wooden rod. Wooden rod. So wooden rod is needed to fix these balls. Okay, otherwise they might fall off. Otherwise there is no way to hold these things. No, they will fall. So therefore we have to get a wooden rod. For instead of a wooden rod, you can use even a string or else a metal bar. No problem with that. Okay, to hold these planetary structures, you'll be needing this rod. Then of course you'll be needing some threads. Then glue and a rigiform board. A rigiform board, right? Rigiform board in order to take these, like if you want to build up several things, if you want to cut like the Saturn's rings, in order to take these rings, we'll be needing a rigiform board to cut these things. Okay, right? So these are the materials you'll be needing. You'll be needing several balls like plastic or rigiform, paint, wooden rod, threads, glue and regiform board, my dear children. Okay, so now let's head on to see what is our method or how to conduct this activity. So select styrofoam balls to the sizes given below and paint them with colors indicated. So my dear children, styrofoam means the regiform balls. Okay, I told you that instead of regiform balls, you can use any material. It's not going to be a problem. But however, remember their sizes should be like this. Okay, sizes means the diameter of the ball should be like this. Okay, at least nearly should be like this. So that's why I told you that regiform ball is the one which is most easier, right? Regiform balls are the one which is more easier to conduct this activity, because by using regiform balls we can cut according to the sizes which is given in the board, right? However, you can use any balls. It's not going any ball, right? Any kind of a material. It's not going to be a problem. But however, their dimensions should be according to these values. And my dear children, after that you have to color these things. You have to color the surface of these things by using these colors. Okay, by using these colors, because each and every planet, they show different colors, a unique color, right? So if you take the planet Earth, my dear children, it has a planet Earth, it has a dark blue nature, because you know that our planet Earth, it contains water. So when you go, if you can go to the outer space and if you can check the surface of the planet, then you'll be observing a darker blue planet. You have even heard that our planet Earth is called as the blue planet because it contains water. So even you refer the figures, right, of planet Earth, you can observe the same scenario. So different planets, my dear children, when you observe from the outer space, they show different like unique colors. If you check the sun is like in yellow color, my dear children, right? So I told you that sun is like in yellow color, related to the yellow color. Okay, if you take Jupiter, see, Jupiter is like in orange color. If you take Mars is called as the red planet. I think you can remember that Mars is called as the red planet. So there are unique colors when you observe from the outer space. Each and every planet shows a unique color. So that's why these colors are important. So my dear children, you have to select the diameter of the balls, right, according to these dimensions, and you have to color the surfaces by using these colors. So we'll see what are the dimensions. So diameter of the ball, first one should be 15 centimeters. It is the largest one. You know that our sun, it is the largest celestial object in our solar systems, the sun. It should be 15 centimeters, the largest one. Then Mercury, only 1 centimeter of diameter. Venus, 2 centimeters diameter. Earth, 2 centimeters diameter. Mars, 1.5 centimeters of diameter. Jupiter, 10 centimeter of diameter. Then Saturn, 9 meter is the diameter of the ball, and 12 centimeter is the diameter of the ring. Okay. Then Uranus, 5 centimeter. Then Neptune, 4 centimeter diameter. Right. Then the colors. For Sun, we'll be using yellow. For Mercury, orange. For Venus, bluish green color, right? You can mix blue color and green color together, right? And you can paint it. Then my dear children, dark blue is for the planet Earth, red color for the planet Mars, orange color for the planet Jupiter, yellowish orange for the Saturn, and Uranus, light blue. For Neptune, once again dark blue. So these are the colors and their diameter, the dimensions. Okay, the diameter of the ball which you are going to take, and for the Saturn you have to separate a ring also, right? You can use that regiform board to cut that ring, my dear children. Remember, the diameter should be equal to 12 centimeters from the center, right? So these are the colors and the diameters of the balls. Okay, so what you have to do, you have to take these balls, my dear children, then now with these dimensions, and you have to color these things according to the given color, right? Then cut a ring for Saturn from the styrofoam sheet. When the paint is dry, fix balls to the wooden strip using glue. Paint the wooden strip black. Make the model as shown in the figure. Write the names of the planets. Alright. Now what do you have to do? After you have prepared these balls, like according to the given diagram here, you have to paint these things by using those colors which is given in the earlier given in the earlier slide. According to those colors you have to paint it, right? Then after that, when the paint is dry, you can use a piece of thread and you can hang these each planet according to the diagram given using the metal or the wooden stripe or the rod. Okay, you can paint the wooden stripe or the wooden rod by using black color. Then my dear children, you have to prepare the structure according to the given diagram here. So it's very simple, right? It's very simple. So this is the structure of our solar system. So this is how solar system is arranged in our space. Okay, so my dear children, as you can see here within the figure, these sizes actually represents, or it's to the ratio of the planet. Okay, it's to the ratio of the planet. That's why we have to use according to the given amount, according to the given dimension. It reflects the ratio of the diameter, right? So therefore, actually not the real size, my dear children, but however up to a certain ratio, right, it's been mentioned. So by that way you can get some kind of an idea about their sizes. So remember to take the balls according to the same ratio given in the earlier slide. Okay, right then. So let's head on to the lab, my dear children. I have a system that I have already prepared. Okay, so let's head on to the laboratory. We'll observe the structure and let's identify the planets once again. So my dear children, this is a structure which made to demonstrate the arrangement of our planets in our solar system. Now first of all, at my far left corner you can observe the yellow color ball over here. That's the sun, the largest of all, right? So after that, at some kind of a distance, you can observe the Mercury, planet Mercury. So when you compare the size of planet Mercury with the other balls, if you can see it very clearly. If you compare the size, it has the smallest. So Mercury, the smallest planet in our solar system. Then after that, when you go somewhat right from Mercury, you can observe the second planet in our solar system, which is the Venus. Then after the Venus, you can observe the blue color one over here, the third one. So blue and greenish color planet, the planet that we are going to live, right? This is the planet that we are living in. So planet Earth. So planet Earth, the third one from the sun, right? This is the planet, the only planet which we can observe the life within the solar system. So it's the third planet from the sun. Then after that, in red color, somewhat similar to the size of Earth, right? you can observe the planet, red planet, which is referred as the Mars, right? So the Mars, the fourth one. After that, you can observe the longest ball among the planets, which is in orange color. This is the Jupiter, planet Jupiter. There's a special fact about the Jupiter, my dear children. It's that there's no kind of a crusty surface in planet Jupiter. It's like an air balloon, right? There's no crusty surface in it. Just a bunch of gases and dust particles. That's it. There's no crust in planet Jupiter, but however, it is the largest planet that can be observed within the solar system. After the Jupiter, you can observe the planet Saturn. That's the planet which has that awesome rings around it, right? The dust rings around it. So there is another fact about Saturn. It's the second largest planet of our solar system, right? Saturn. After the Saturn, when you go further, you can observe the icy Uranus and finally Neptune, right? So there was another planet in our solar system which called as the Pluto, but however, scientists have removed that thing from our solar system because it's been mentioned that in order to be a planet, there should be certain specifics. So Pluto is not following those kinds of specifics. So therefore, Pluto has been expelled from our family of solar system. Right now, up to now, we are going to identify, we are mentioning that only these 8 planets are there in our solar system. Earlier there was 9, including with Pluto, but however, in recently, scientists have removed Pluto from the solar system, the family of solar system in our solar system like this. So these are the planets once again in our solar system. You can observe the closest one, Mercury, then Venus, then Earth, Mars, Jupiter, Saturn, right? Jupiter, Saturn, then Uranus, then finally Neptune. These are the planets, the 8 planets that contained in our solar system. Right then, so let's head on to the classroom once again and we'll see what are the other things contained in our lesson. Right, my dear children, so you have observed that structure. So it's easy to prepare that structure, my dear children. Like I said, if you can find several balls according to those sizes, you can use any material. It's very simple to make that structure, and by that way we can easily identify, right? By that way we can easily identify their, if you take the planetary system, right? If you can easily identify the planets and their sizes, my dear children. But however, there is a special thing. I told you that these sizes are not the actual sizes. These sizes are not the actual sizes. So it is given in here. The ratio of the sizes of the planet is not indicated in the model which you made in the activity. The real ratio of the sizes of them is given in the figure. Now within this figure, the real ratio can be observed. Okay, the sizes. So here you can observe the planets, my dear children, right? So within these planets, you can observe the real sizes. Okay, the real sizes can be observed. So here, so the size comparison is given within this figure. The Mercury, smallest one, Venus, Earth, Mars, Jupiter, Saturn. Then here you can observe Uranus. In Uranus also, my dear children, you can observe, if you see it very clearly, if you can zoom in, right, then you can observe like there are several, rings around the Uranus also. Okay, then Neptune, the final one, and you can observe there is another one over here, right? Let's count the planets in here. 1, 2, 3, 4, 5, 6, 7, 8, and there is a 9th one also in here. Now this is the one which I have already told you in the earlier case, my dear children, the Pluto. right? So it's been expelled from our solar system. I told you that the ninth planet. Okay, so it's not considered as a planet. I told you why is that, because it takes much longer time to revolve around the sun, so it's been expelled from our solar system. Okay, so these are the this is to comparison the sizes, no? So by looking at that thing also you can get a certain idea about the planets. Okay, a certain idea about the planets. So if you consider the Pluto and Mercury over here, as you can see, Pluto is even more smaller than the Mercury. So there is also a reason to expel this thing, because when a planet is going to be smaller in size, it cannot be considered as a planet. Most of the times it may consider as an asteroid then. An asteroid. Okay, so that is also a reason for expelling Pluto from the solar system, because it is way more smaller to be considered as a planet. Okay, right. So these are the size comparison of our solar system to get a small bit of an idea about their sizes, my dear children, right? However, you ignore about this thing because it is being expelled from our solar system. These are the 8 planets which included in our solar system right now. Once again, Mercury, Venus, Earth, Mars, right? Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus and Neptune, right? Okay then, so we'll head on to see what are the other contents. So now there is another activity which is given here. So within this activity, my dear children, we'll be understanding about the distances of planets from the sun. We'll be understanding about the distances, right? Now in the earlier case, we studied about the sizes, no? We compared the sizes. So here we'll be identifying about the distances from the sun in how much of a distance. From the sun in how much of a distance. So we'll be mainly focusing about the distance within this activity. Right then, so let's see what are the materials that we need. First of all, you'll be needing name boards. Right? So name board of planets. A name board of planets. Then a meter ruler. A meter ruler, or else a scale can also be taken. Scale means you can use a measuring tape, a measuring a rod, like that way. Now we have to measure the distances, no? So any material or any instrument that can be used to measure the distances, remember it. Okay, we'll be using, most of the times we'll be using meter ruler, but however, if you can use a tape also, then it's not going to be a problem. However, we're going to measure the distance from here, right? We're going to measure the distance. Then balloon. Right? Balloon. So it's really simple, my dear children. These are the materials you will be needing. A name board of planets, meter ruler or else a scale, a suitable scale, right? Then you'll be needing balloons. Right, then let's head on to see what is the method. Place the inflated yellow balloon at the center of the ground. So at the center of the ground, you have to place the balloon. Okay, you have to place the balloon. Then apply slaked lime on the circles marked on the ground. Place the name boards of the planet of each planet on each circle. Position a student at each name board. So you have to place the balloon at the playground. Then you can use lime or any other marker to mark the positions. Then you have to use that name board, separate one name each and assign a student for each position, each marked position. Then give each student at the name board a leaflet with information of that planet. Direct students in your class at a time to each name board. Alright. So now you have to give out, you have to get that certain information about the planet. We discussed about those informations earlier. So just give it a small leaflet regarding the information of that particular planet which each student is going to represent. Okay. Direct the student at the name board to describe about the planet that he is responsible of. Now, around the yellow color balloon, my dear children, students are being assigned now. So these students are given with a name board. So these name boards represents the planet in our solar system. So the person who is having that name tag is the one who represents that planet. Okay. So my dear children, what you have to do? Give out a small bit of a leaflet regarding the information of the particular planet. Then when the time comes or when the turn comes, he or she should have to read that information to the class and represent them. So this is a very simple activity that you can do it in your school or with your friends at your playground or at your school playground. Okay, right. So I hope that you will follow up with the activity and you will do it. So it's really simple. Then the next thing, when you take this thing, my dear children, now I told you that we have to mark the distances. Here we are comparing the distances. So when you are marking these distances, my dear children, I told you that we have to use a scale. When you are using this scale, you can use any kind of a scale. Here we are going to take a measurement. So meter ruler would be great. But however, right, you can use any kind of a measuring tool. So here we'll be using the ratio of the distance from the sun. So for Mercury, it should be 0.5. And for Venus, it should be 1. For Earth, it should be 1.5. For Mars, it should be 2.2. Jupiter, 7.8. Saturn, 14.2. Uranus, 28.7. Neptune, 44.9. Right? So these are the values, my dear children. As you can see here, there is no exact value or exact unit is given. So how can we do this thing? What's the method of doing? It's really simple. You place the balloon like this. Then after that, you measure the distance. Now you have a certain scale. No, we'll imagine that you guys have a meter ruler. So first one should be 0.5. At a 0.5. 0.5 means at around 50 centimeters, you have to mark one place. 50 centimeters. Then in the next one, 1.08. That means 1, no, rounded off 1. So the second scale should be exactly 1 meter. Then the next one, 1.5. 1.5 means 1 meter and half, means altogether 150 centimeters. You can use the meter ruler and you can measure. Then the next one, 2.28. 2 meters and another 28 centimeters. So altogether 228 centimeters. Okay. So 2 length of meter ruler and another 28 centimeters for the next one. Then 7.78. or simple 7.8. So 7 meters and another 80 centimeters. This is from the balloon, okay? From the balloon, the distance, right? Then my dear children, 14.2, 14 meters and another 20 centimeters. 28.7, 28 meters and another 70 centimeters. 44.9, 44 meters and another, how much? 90 centimeters. Almost 45 meters. So by that you can get a certain idea how much far does each planet located from our sun. Okay, how much far? You can clearly identify the distances, the ratio between the distances here. So as you can see here, the final planet, which is the Neptune, is like 45 meters away from that balloon. It's like going way more than that. The final one. So this is how to do a simple activity to identify. Right, a very simple activity to identify their distances, to compare their distances. There means here the planets. Okay, planets. Right, my dear children. So as you can see here now in laboratories, now this is for you guys. You can do it at your school or else outside the house. In a playground or at your home garden. You can do this by collecting several students or several friends of yours. You can do this thing. And but in like laboratories, we develop or we have a special structure in order to identify the distances, in order to get an idea about the distances from the sun to each planet. Okay, so this is that structure which is given. Here we are using several plastic or styrofoam balls. So here, see. So now I think you know that you have a comprehensive idea about the planets and their distances. Okay, so this figure is going to show a model of solar system in the school laboratory. So in our laboratory, my dear children, there is a different kind of a structure to identify the solar system, right? So this is that structure. Okay, so this structure is being used at laboratories to identify the planets. Right, my dear children. Now, within this activity, we'll be identifying a special property. So these properties will be studying about the revolution of planet around the sun. So you know that our planet, if you take our planet Earth, it's going to revolve around the Earth, no? Each and every planet also going to revolve around the Earth. Each and every planet revolves around the Earth. We know that. So my dear children, by doing this special activity, we'll be identifying what is the reason. Like what kind of a reason is this? What kind of a reason is the reason cause, right, for the revolution of these planets? What is the special reason? What kind of a reason is the causative agent for this revolution? Right? There should be a reason, no? So otherwise the planet should go travel here and there, right? In order to rotate around a certain object at a constant speed, at a constant path, there should be a reason. So you know that it's the gravitational force. But however, by doing this activity, we'll be identifying the effect of it. Okay. So it's a really simple activity, my dear children. We are going to use a small bit of a ball, and by using a thread, I'm going to rotate it around my arm. Okay, I'm going to rotate it around my arm. So as I'm going to rotate it, I can see that as long as I am applying the force, as long as I am applying the force to rotate the object, or here the ball is going to rotate around my arm. However, when I am going to stop the application of force, definitely the rotation of the ball will stop and it will come down, or it will fall down. Okay, so this obvious observation could be observed for sure. So you can observe, you will observe that thing when I am going to conduct the activity also. So first of all, we'll write down our materials, my dear children. So we'll be conducting this activity at our laboratory also. So first of all, we'll observe the special things. We'll observe the materials which we need, right? So the materials, we'll be needing a thread and a plastic ball. Rubber ball also can be taken. Right, plastic or a rubber ball can be taken, right? So these are the materials you need. So it's really simple. You just need to fix this thread onto the plastic or to the rubber ball. Then you have to rotate it around your arm by applying a certain constant force, right? So the method: tie the ball at one end of the strong string about 50 centimeters long, right? So according to the space that you have, you can change the distance, my dear children. You can change the length of the thread. It's not going to be a problem at all. But here we'll be studying about how the revolution works now. So don't worry about the length of the string. You just take the string, and according to the space that you have, you can either minimize, or you can even, if you want, you can even elongate it, or else you can use a even more lengthier string. It's not going to be a problem. The length don't matter, right? Then take the other free end of the string to the hand and rotate the ball fast enough above your head. So as I told, according to the space that you have, my dear children, you can either rotate it like this, or else you are around your head also, no problem, right? So you take the ball, and by applying a certain force, you rotate it. Then now observe the manner ball rotates around you without falling until you rotate it. So what you have to do then, while you are going to rotate, observe the rotation of it, how it's going to rotate. Observe the rotation and see that the ball is keep on rotating without falling or without moving to any other different place. It always rotates to a same, it always rotates in a same path, a constant path. The path is not changing. In order to change the path or change the orbit, you have to change the force given by your hand. By that way, the path or the orbit is getting changing. However, if you provide the same constant force, then, my dear children, the path is not getting changed. You can observe that the same path is going to, the object is going to rotate, or the ball is going to rotate in the same path. Okay, right? So my dear children, this is the way of doing the activity, right? We'll head on to the lab and we'll conduct this activity. Then, my dear children, we'll once again come back to the classroom and we'll write down what is our observation from that activity and our conclusion. So once again, we'll head on to the laboratory and we'll conduct the activity, and let's identify the special features regarding these revolutions. So my dear children, to observe the rotation of planets around the sun, or here to observe the rotation of a moon around a planet, same thing is going to occur in the same way, right? I have with me a ball fixed to a thread. Now I'm going to show you, after rotating this thing, I'm going to show you that the ball is not going to, it's not going to change the path, and it's going to rotate in the same way, in the same path, as long as I'm going to supply the force from my hand, right? So I have a ball with me fixed to a thread. Now I'm going to rotate and show it to you what's going to happen. So we'll rotate. Always remember, when you're rotating, we have to rotate it like this. So observe the path of the ball very carefully. As long as I'm supplying the force, it's getting rotated without any trouble, and always it is maintaining the same pathway around my hand. The pathway of the ball is not going to change from time to time. Always it is rotating at a circular path. You can see it very clearly, right? So reason for this thing is, when I am applying force by using my hand, right, upon that force the ball is rotating at a circular path because of application of that particular force. Now in the same way, if this is the sun, this is the planet revolves around the sun like this because of having this kind of a force. The force which binds the sun with the planet is referred as the gravitational force. So the two gravities creating one on each other is the force which resulting this rotation around the sun. And also the same thing is going to happen when a moon is going to rotate around a planet, right? So the same path or the same elliptical path is maintained as long as the gravitational force is there, right? So the two gravities are going to interact each other upon the rotations of planets and the moons, right? Then, so by looking at this activity, you can see that clearly the gravitational force is the one which is going to affect for the motion of the planets and motion of the moons. So my dear children, let's head on to the classroom once again and we'll see what are the other contents in our lesson. Right, so we conducted the activity, my dear children, as you can see, right? I think you have observed the rotation very well and the revolution around my arm. So our observation was quite simple. What was that? As long as I am providing the force, the ball rotates around me at a constant speed. How can I say that it is a constant speed? It's because that I can see that the ball is moving at the same speed, right? The speed of the ball is not going to change. I can see that it's moving on the same speed, same constant speed. It's not changing. So as long as I'm providing the same force, it's going to rotate or it's going to revolve around me with the same constant speed. It circulates with the same constant speed. And my dear children, the other thing is that the ball speed of the ball is not getting reduced, it is not falling into my hand, or it's not moving away from my hand. So the thread is going to act as a, it's going to keep the same rotational axis or the same rotational orbit. The thread helps to keep the same rotational orbit of the object. Okay, so our observation was very simple, my dear children. What was our observation? We can write the ball rotates at a same constant speed around the arm. Okay, arm or the head. So I have rotated around my arm, so that's why I have written as arm. Okay, so if you are rotating around the head, then you have to then you can write as head, no problem. I have rotated, in order to show you guys, I have rotated around my arm, so that's why I have mentioned it is as armed. Okay, right. Then the conclusion, my dear children, why it is rotating at a constant speed around the arm? It's because that you know that this is the sun. So we'll take our usual example, the rotation of the ball. So this is the ball, this is the thread, and this is my two fingers which I am holding to rotate this thing. Okay, so I'm rotating this thing. I'm applying a force and rotating. So when I'm going to apply a force, right, let's say that applying a force like this. So upon application of that force, this is going to rotate at this kind of a path. The rotation. This is the ball. So my dear children, I am applying a certain constant force in here. This is the thread. This is the thread, and I am applying a certain constant force in here. So when I am going to apply a certain constant force, always due to that constant force, the object or the ball is rotating at a constant path. And my dear children, the other case is that if you take the ball, there is a possibility that the ball would come towards you or it will travel away from you. However, that thing is not going to happen. Why? Because I am applying a constant force by my arm. By my arm, I am applying a constant force. It helps to keep that original path as it was. If I am going to change the force, in that case, my dear children, the path may change. Okay, in that case, the path may change. The thread is going to act, or it's going to transmit the force which I am applying by my hand. Okay, thread is going to transmit the force which I am going to apply from my hand. So in the same way, the planets are also revolving or rotating around our sun. How come? There is no thread? No. Someone is not rotating it? No. Even though there is no thread, my dear children, there is a way of transmitting a certain force from our sun towards the planet. That force is referred as the gravitational force. So the gravitational force is getting transmitted towards the planet, and that gravitational force is going to help to rotate or revolute this planet around the sun. We can't see it, but however, the force is getting transmitted towards the planet. That is why the planet is revolving around the sun. In the same way which I have transmitted a form of energy, a form of force, by using a thread and by using my arm. Only thing which is going to differ at the celestial objects is that there is no thread to transmit. There is no material to transmit the force. However, the force is getting transmitted, right, with the help of the space-time continuum. It's referred as the space-time continuum, the space that we are living in, the environment, the space, whatever the thing that we are living in is referred as the space-time continuum. So the space-time continuum is the one which is going to transfer that force towards the what? Ball, right? Towards that large ball. That large ball is the planet. Okay, right, my dear children. So the application of gravitational force is the main reason behind this rotation or the revolution. So we can write the conclusion, my dear children. Due to application of due to application of a constant force on the ball, it rotates around the arm. In constant speed at a same path. So due to application of a constant force on the ball, it rotates around the arm in constant speed at a same path, right? So same path means the same orbit. So as you can see here within the figure also you can observe it, right? So when I'm going to rotate it, it's rotating around the same path without moving into either of the directions, away or towards, right? It's not going to be a problem. In the same path, it's going to rotate always. It's because the same force, a constant force, is getting applied from the arm and by the thread on the ball, right? So this is identical to the revolution of our planets. So planets are revolving with the help of gravitational force applied by the sun. So that gravitational force is transmitted towards the planet from our space-time continuum. Okay, from the space, you just mention it as a space, right? From the space, the gravity is getting transmitted. Now, in order to apply a certain force on a certain object, right? If I'm here, then if a certain object is somewhat away from me, then I have to use a certain type of a material medium to propagate my force. But however, in this case, right, the space itself is going to help to transmit the gravitational force, Okay, the space itself is going to help to provide or to support that in the application of gravitational force. Okay, my dear children, so gravitational force is a special kind of a force that is being provided for the rotation or for the revolution of the planets by our sun. As the sun is pretty much larger, the gravitational force given out by the sun is also that much huge. Right then, so this is the reason for revolution of planets. So the revolution of planets occurs, my dear children, because of the gravitational force given out by these things. Gravitational force. Right then. So in this activity, you might have observed that the ball rotates in a circular path without attract towards you. This rotation can be explained as follows. So here, as you can see, the rotation can be explained by using the figure. You can see it. The same constant speed is given, right? So as you can see here, you just may refer the figure, then we'll go for the explanation. Here a force is exerted from your arm to the ball. Now we are exerting a certain force on to the ball by our arm. Therefore, ball is rotated in a circular path at a constant speed. We know that, right? Then, corresponding to the example given in the figure, revolution of planets around the sun also can be explained. Comparative to the force applied by the arm towards the ball, a force is applied by the sun towards the planet. That is called gravitational force. So according to the diagram given here, my dear children, right? Because of the gravitational force, this thing always rotates around a constant speed, right? Like this, always going in a constant speed because of the gravitational force around here, right? So gravity is the main reason for the rotation of these celestial objects. Actually it's not the rotation, it should be revolution, as it is rotating around a certain object, right? So due to this revolution thing happens mainly because of the gravitational force, mainly because of the gravitational force. So once again it is given, my dear children. Let's see, a force is applied by the sun towards the planet, and that is called as the gravitational force. So this rotation or the revolution occurs mainly because of the gravitational force, right? So gravitational force is identical, it is same as, right, it is same as the force which we have applied by our arm to rotate that particular ball. Okay, the planet should fall on the sun and be destroyed due to this force, but this does not happen because of the constant speed of revolution of the planet around the sun. Now during the rotation, my dear children, I told you that there is a chance that the ball or the planet will come and meet with the surface of the sun, and it will fall to the sun and will get destroyed. But however, that thing is not going to occur. I told you that because in this moment, as long as the force is getting applied, as long as the same constant force is getting applied, the object is rotating around the same path at a constant speed. If the speed is getting changed from time to time, my dear children, in that case, there is a risk. Then there is a risk like that. But however, this rotational speed is never changing from time to time. This rotational speed is never changing from time to time. So therefore, my dear children, right? Therefore, my dear children, the object or the planet is not going to fall onto the sun, right? When I am rotating that ball, you could clearly observe that the ball is rotating around my arm, without falling or without hitting on my arm. Okay, it's not going to fall and it's also not hitting on my arm either. It's because I'm applying a same constant force. If I'm going to apply different forces at different intervals, in that case, my dear children, the ball will definitely fall down, okay, or else the ball will definitely come and hit my arm, right? But however, none of this is going to happen if you are applying a same constant force. So here also a same constant gravitational force is getting applied by the sun on the planets. So therefore there is no change in it. It's going to keep the same constant speed and it's going to maintain the same constant orbit and keep on rotating, keep on revoluting around the sun at a constant speed, at a constant path, right? So this is how the gravitational force affects the revolution of the Earth and other planets around the sun. So what happens if the gravitational force reduces or increases? In that case, my dear children, in that case there is a risk of moving away planet to a different location or else going to hit the surface of the sun. But however, that thing will not occur at all because our sun is going to provide a same constant gravitational force. Okay, if the gravitational force is going to change, then that incident would happen. However, right, the same constant gravitational force is getting applied, so therefore there is no need to worry about that thing. Right, my dear children, so I hope that you got a good knowledge about how the revolution works, right? So this is how the revolution of a certain object around a certain planet or else around the sun works. So I mentioned now, like seconds ago, I mentioned around a planet. Is there any other thing which is going to rotate around our planet? And of course there is. The rotation of satellites. The rotation of moon around the earth also occurs according to this model or according to this method, my dear children. It's because the gravity exerted by our earth on those particular objects also helps to maintain a constant path around our earth. You know that in each and every month, my dear children, we can observe a full moon. In each and every month, there are certain instances where there is no moon. This is called as the new moon, right? So you can see that moon is also rotating around our earth at a same constant speed. Otherwise, for 1 month, right, if you take a 1 month, so one certain month, there shouldn't be any kind of a new full moon, any kind of a new moon. We won't be able to predict when the new moon or the full moon is going to come in the next month. We won't be able to predict even if it is not rotating at a constant speed, right? So we can determine these things because the moon is also rotating in around our earth at a constant speed. Okay, at a constant speed. So this helps to determine the new moon days and the full moon days in the months which are coming ahead, right? So this phenomena also works. The rotation of or the revolution of moon around our planet Earth also works because of the gravitational effect given out by the Earth. And also, my dear children, I told you that about the satellites. So if you take a satellite is also rotating around our Earth. I told you at the beginning of the lesson part, for the global positioning systems, GPS, and for the tracking of mobile phones, right? When you are taking data connections, internet connections, For these connections, satellites are pretty much important. So, the satellites are also going to rotate around our Earth at a same constant speed. It's because of the gravitational effect or the gravitational force given out by our planet Earth. Okay, if you take the ISS or the International Space Station, the same process or the same scenario can be observed, right? So each and every revolution that occurs in celestial objects, my dear children, happens because of the gravitational force. So the same gravitational force is going to effect on each and every object, right? So this is called as the revolution. So I hope that you got a good idea about the revolution process, my dear children. The revolution of planets and other celestial objects mainly occur because of the gravitational force given out by each and every larger celestial objects. Okay, larger celestial objects. So when you compare the size of planet with the size of a moon, planet is way more larger than the moon. That's why it is referred as a subplanet or else a moon, right? So the gravitational effect given out by the planet, the larger one, is way more greater than the other. That is why the subplanet is rotating, doing the rotation or the revolution around the certain planet, right? In the same way also, the satellites and any other instruments or machines is going to work, right? They are also rotating around our Earth at the same scenario according to the same explanation, right? Then, so my dear children, with that information, I'll be winding up our second chapter related to the lesson part. So in here we discussed mainly about how the rotation and the revolution occurs, and we got a sound knowledge about the distances from the sun to each and every planet in our solar system. And my dear children, we took a good knowledge about the size comparison of the solar system, right? Size comparison of the planets in our solar system, and we identified several other factors which are important for the motion of planets and other celestial objects. So my dear children, in the next chapter we'll discuss further more things related with the lesson.
To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.